Welcome students, grade 9 introduction to coordinate geometry in our Ganit Manjari. This is your first chapter, coordinate geometry. Look at the introduction part. You can see the plane figure, all the plane figure made up of infinitely many points. Here the pink box, inside the pink box I'm going to place some points. The pink box made up of infinitely many points, I'm going to place some points. When I'm naming the points, A, the first point is A, then this is B, then this is C, D. Likewise, I can use my alphabets and I can name the point. When you need to find the position of the point, you can use your horizontal and vertical method. Horizontal, column 1, column 2, column 3. This is vertical. Then horizontal, row 1, row 2, row 3. This is vertical arrangements. When the vertical and horizontal line are meeting each other, that position is nothing but position of a point. This is nothing but position of a point. Using this horizontal line and vertical line, we are dividing a plane. No, that plane is called as Cartesian plane. That the system of writing number is nothing but Cartesian system. Look at the Cartesian plane. In a Cartesian plane, this is the way to divide the Cartesian plane. When we are dividing Cartesian plane, the horizontal line is called x-axis, x and x dash. The vertical line is called y-axis, y and y dash. The two axes are meeting each other at a point O. That is nothing but our origin. O is the origin. We can divide this line into equal parts. 1, 2, 3, 4, 5. We can name 1, 2, 3, 4, 5. Because the OX, that is right side of the origin, is nothing but positive side of x-axis. Then above the origin is nothing but positive side of y-axis. Then 1, 2, 3, 4, like that you can number the axis. Then left side of the origin is nothing but negative side of x-axis. This is positive side of y-axis above the origin. Left side is nothing but negative side of x-axis. So minus 1, minus 2, minus 3. Likewise, we need to number there. Then below the origin is nothing but negative side of y-axis. So here we could number as minus 1, minus 2, minus 3, minus 4. Likewise, this is the Cartesian system of writing the numbers. Okay, when I'm saying xo x dash, this is nothing but one axis, so axis. Then xo y dash is another axis, both together called as axis. So axis is a singular form, axis is the plural form. Here when we are keeping a point, if I am keeping a point A here, I can find the position of A. I can find the position. How to find the position? Look at here, keep your scale and find which column it belongs to. Look at here, this belongs to the third column. So write that number first, third column, comma. Then which row it belongs to. So draw the line. So fourth row. So 4. So that point belongs to the third column and fourth row. So when you are plotting a point, I plotted a point A. When I am plotting a point A, 3, 4 is the position of the point. That is, A belongs to third row and fourth column. In this way, when we are plotting a point, A of 3, A of 3, 4. Together, the 3, 4 with ordinary bracket separated by the comma together is called the coordinate point. That is nothing but coordinate point. So here I mentioned that together the name is nothing but coordinate point. In that, the only coordinate point. So when we are taking 3, the name of 3 is nothing but abscissa. That is x coordinate. X coordinate point name is abscissa, and 4 called as ordinate. That is y coordinate point called as ordinate. So abscissa and ordinate together called coordinate point. So what about the abscissa and ordinate of origin? That is nothing but 0, 0. Abscissa is 0 and ordinate is 0, means that is origin point. Then you know that OX dash is negative side and OY dash is negative side of y-axis, and OX is positive side of x-axis, OY is positive side of y-axis. Now the Cartesian plane divided into 4 parts. This is first quadrant. Each part called as quadrant. That is first quadrant, this is second quadrant, third quadrant, fourth quadrant. Okay, look at here, first quadrant belongs to x, o, y plane. Second quadrant means x dash, o, y. Third quadrant means x dash, o, y dash. Fourth, x, o, y dash. So look at here, first quadrant, our first quadrant. So this is the origin, x-axis, this is y-axis. You know origin, right hand side positive and above the origin positive. So each point belongs to the plane is nothing but plus comma plus. Our abscissa are also positive and ordinate is positive. Look at the second quadrant. This is our origin, then this is our y-axis, this is our x dash axis. When you are plotting a point here, what the sign can you get? Left hand side of O is negative of x-axis and above is positive of y-axis. So you will be getting sign as minus comma plus. Abscissa is minus and ordinate is plus. Look at the third quadrant. Which plane it belongs to? This is the origin and this is x dash. Left hand side of origin is nothing but negative and below the origin is y dash, that is also negative. So the point belongs to the third quadrant. Sign is minus comma minus. Look at the fourth quadrant. Here the plane is nothing but origin and positive side of x. So plus OX is positive and below the origin y dash. So negative side of y. So positive comma negative is the sign of the point in the fourth quadrant. So without plotting the point, looking the point itself, we could understand which quadrant it belongs to. For example, minus 3 comma minus 2, both are negative, so this belongs to the third quadrant. Suppose I am writing 5 comma minus 2, x is positive and y is negative, belongs to the fourth quadrant. Suppose both are positive, belongs to the first quadrant. Suppose y is negative and x is positive, belongs to the second quadrant. Like that, seeing the point itself, we can find which quadrant it belongs to. Now few points does not belongs to the any quadrant, like that, like this. See, few points. I'm going to take a point on a axis. So as you know, this is the origin 0 comma 0. Suppose I'm going to take a point here. So what should be its coordinate point? It is below, it is on the x-axis. So from here 1, 2, 3 means 3 comma nothing in the ordinate place, that is 0. Then if I am going to take a point here, so 1 and 2 means this is nothing but 0 comma 2. Like this, if I am getting a point for x comma 0 or x comma 0 or x minus x comma 0, y comma 0, 0 comma minus y, those are the axis point. They are does not belongs to any quadrant. They are on the axis. Okay, when we are talking about distance between 2 points in a Cartesian plane, we can find the distance between 2 points. That is nothing but 2 points, a of x1 y1 and b of x2 y2 means the difference x2 minus x1 the whole square plus y2 minus y1 the whole square is nothing but this much of unit will give the distance between the point A and B. Suppose A is a point and B is a point, we are going to find the distance from the origin, means that is nothing but, you know, origin point 0 comma 0. So x1 minus 0 the whole square plus y1 minus 0 the whole squared is nothing but x1 squared plus y1 squared. What about this? x2, y2 are the points of the coordinate points of B. So x2 minus 0 the whole square plus y2 minus 0 the whole square is nothing but square root of x2 squared plus y2 squared. From the origin you can find the point. Okay. Now say a point A of 4 comma 3. Okay. See here 4 and look at here 3. So coordinate point of A is 4 comma 3. Now what is the distance of A from y axis? What is the distance of A from y axis? That is nothing but your distance of the point from x axis, this or abscissa, 4 units. So distance of a point A from y axis nothing but its abscissa. Distance of a point from x axis is nothing but its ordinate, 3 units. So when we are calculating the midpoint of any 2 point, nothing but average of these two. How to find average? We will sum up the number divided by how many numbers are there, we need to divide. So there are 2 points, x1, x2, these are the abscissas. Summing up these two and dividing by 2, you will be getting midpoint of these two, and ordinate y1, y2 by 2, you will be getting midpoint of AB. Thank you. Look at the first question. What are the coordinate, x coordinate, what are the x coordinate and y coordinate of the point of intersection of two axes. Point of intersection of two axes. What are the two axes? You know very well. One is x-axis, another one is y-axis. Look at the, visualize the Cartesian plane in your mind. This is x dash is the horizontal axis, and y dash. No need to draw this and all, just visualize. Then you can find it easily. For everything, you no need to draw. For the explanation, we are drawing, but you no need to draw all the things, just visualize and find. The horizontal line and vertical line meeting each other at the origin. So, two axes meeting, the intersection of two axes, nothing but origin. So, intersection of two axes is the origin point. So, how the origin point coordinate, x coordinate, origin x coordinate is nothing but 0. Then origins y coordinate is nothing but 0. So, both are 0. Okay. So, that is nothing but O of 0, 0. See the next question. The point W. Now, you're going to have a point W. X coordinate of W is -5. So, write the point. W, x coordinate is -5, y coordinate not given. So, the point W like this. So, where it should be the point W? -5. X coordinate is -5. Definitely, once again, visualize this. So, no need to draw. This is our origin. Left hand side of our origin is nothing but negatives. Right hand side of origin positive. So, if I am taking 1 centimeter scale, -1, -2, -3, -4, -5. So, this is the point. -5, 0 or anything, -5, y is given, and what is given? That y parallel to W parallel to y-axis. Definitely, when the axes are same, then the line through W, which is parallel to our y-axis. Which is our y-axis? This is our x-axis, x dash, and this is our y-axis, y dash. So, when a line through W, okay, W is a point. So, when a line through W, if I am drawing a line, so this is the line through W, which is parallel to y-axis. Now, what is given? H, which is on the line through W. Now, the line parallel to y-axis. Now, one more point is there. That point is nothing but our H point. Where it could be? H point. So, this point may be -5, 0. May not maybe, definitely this point is -5, 0. The same 1 centimeter, if I am taking in y-axis, positive side 1, 2, 3, 4, and negative side -1, -2, -3, -4, like that. This is x-axis positive side 1, 2, 3, 4. Okay. Now, how the points are? Look at there. Here we are having -5, 0. So, suppose I am taking the point here, that is -5, 1. This one -5, 2. This one -5, 3. This one -5, 4. Okay, in negative side, this is -5, -1. This is -5, -2. Likewise, -5, 3. Like this, we will have the point on the line which is parallel to y-axis. Okay, when the line is parallel to y-axis, our abscissas are same. Abscissa -5, ordinate are the different points. So, if you are writing H point, H is nothing but -5, y. Okay, that is the coordinate of H. And another question they asked, which quadrant can H lies? So, which quadrant? According to Y, it lie on quadrant. Which quadrant? What are the possibilities? You know very well, this is first quadrant. What is the sign in first quadrant? X is positive, Y is positive. This is second quadrant. Sign of second quadrant, X negative and Y positive. This is the third quadrant. Sign of the third quadrant is X negative and Y is also negative. This is the fourth quadrant. The sign of the fourth quadrant is nothing but X is positive and Y is negative. Now, our line is on the point and above the origin and below the origin. Okay, that is in the second quadrant and the third quadrant. When our H lies on the second quadrant, what are the possibilities? When y is equal to 0. If y is equal to 0, then h coordinate point will be minus 5, 0, where it should be lie on x-axis. You know very well, when one either abscissa is 0 or ordinate is 0, that does not belongs to any quadrant. Those are the axis points. Now our y coordinate is 0, so that is on the x-axis. Then suppose y is equal to any positive number. That means what? Our h is nothing but minus 5, plus y means that belongs to, that is x is negative. See here, our second quadrant point, x is negative, y is positive. So h lies in which quadrant? Second quadrant. Suppose y is equal to negative. So how h coordinate? Minus 5, minus y. That is abscissa also negative, ordinate also negative, means it lies on the third quadrant. So h lies in the third quadrant. So three possibilities are there. Either h is there in axis, x-axis, or it is there in second quadrant, or it is there in third quadrant according to its y coordinate. Clear? Okay. Now look at the third question. Consider the point R of 3, 0, A of 0, minus 2, M of minus 5, minus 2, and P of minus 5, 2. If they are joined in the same order, predict two sides of RAMP that are perpendicular to each other. Okay. The previous question itself, we saw that. What is the knowledge you got in previous question? When the abscissas are same, then the line parallel to x-axis. Same way here, look at here. If suppose the ordinate, I going to draw, you know, this is your x-axis. Imagine your Cartesian format. Okay, each time no need to draw y dash. Now if I am drawing my line L1, which is parallel to x-axis, so I going to choose a point on that line L1. I going to choose 3 points on the line L1. How my points are? This point. How this point will be? Here, what may be the coordinate point? This one. Some y may get some point, and what is your x point? X is 0 and y may be some point. If I am taking this point, then what is the scale you are taking? This is 1, this is 2, this is 3, means yeah, this point is nothing but 0, 3. Then this point is nothing but your x coordinate is positive and y coordinate is 3. And if you are taking here, your x coordinate is negative and y coordinate is 3. So when ordinates are same, then the line parallel to x-axis. Now what about abscissa? When the abscissa are same, if I am taking a line like this, L2, this is the line L2, this point, how the point? This is on the axis, on the x-axis. So for say 1, 2, 3, 4, 5, 6. So minus, this point is nothing but minus 6, 0. So if I am taking a point here, that is nothing but minus 6, 2. If I am taking this point, that is nothing but minus 6, minus 3. So all the point on L2, the abscissa are same, ordinate differs. And L1, ordinate same, abscissa differs. When ordinate same, the line parallel to x-axis. When abscissa same, the line parallel to y-axis. Now, you know x and y-axis are perpendicular to each other. Look at here. Minus 2 and minus 2, A of 0, minus 2 and M of minus 5, minus 2. Both the points, the ordinates are same. So this is parallel to this one. Parallel to which axis? X-axis. When ordinates are same, the line parallel to x-axis. Then look at another point, M and P. What is that? M is minus 5, minus 2 and P is nothing but minus 5, plus 2. Abscissa are same. When abscissa are same, the line parallel to y-axis. So x-axis, one line is, that is AM line is parallel to x-axis and MP line is parallel to y-axis. Definitely the line AM is perpendicular to MP because X is perpendicular to Y. X axis is perpendicular to Y. So our AM is perpendicular to MP. Now the next question is one side of RAMP that is parallel to one of the axes. The previous explanation itself it is clear. That is the line AM is parallel to which axis? AX axis, and the line MP is parallel to what axis? Y axis. Okay, clear? Now look at the next question, fourth question. Plot a point. Plot point Z of 5 minus 6. Axis is 5 and ordinate is minus 6 on the Cartesian plane. Construct a right angled triangle. So right angle triangle, you know very well, right angle triangle means three sides are there. When two sides are perpendicular to each other, then it is called the right angle triangle. Then the third side is this one. So how to find the third side? This is x, this is y, means this is nothing but square root of x squared plus y squared. You know Pythagoras theorem very well. So hypotenuse of the right angle triangle is nothing but square root of sum of squares of other two sides. Okay, using this we are going to find length of the three sides. Okay, so here I am going to divide my Cartesian plane. How I can divide? So I am going to draw my horizontal axis. Look at here. Take your graph sheet. You can draw for this. You can draw it. Okay. This is our x-axis and draw the y-axis. Yeah, y-axis. Okay. Now take 1 centimeter. This is our origin. X dash, y dash. So here 1, 2, 3, 4, 5, 6, 7. Here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Above the origin, you can take 1 centimeter and write 1, 2, 3. 1, 2, 3, 4. Below the origin, you can take minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. Okay. Now plot the point Z. How to plot a point Z? The axis is positive 5, plus 5. So from here, plus 5. Okay. Then ordinate is minus 6. So this 5 and minus 6, where they are meeting, that is our Z point. This is our Z of 5 comma minus 6. They are asking you to draw the right angle, means from this anywhere you can draw the triangle with any units, any length of the side. So now what I going to do? I going to draw the triangle which is going to meet your axis points. Okay, so look at here. This is my Z. No, I going to join like this, and if I am joining this one, this is my right angle triangle. So join your axis points. What triangle they are asking? IZN. So take this point is your I point and Z point is this one, and this is your N. This is the right angle triangle. Here the horizontal and verticals are perpendicular each other. So this is our right angle triangle. So what are the coordinate points? Now you will have, what is I's coordinate point? I is on x-axis, okay, at 5 units. So 5 comma 0. Then N is on y-axis at minus 5. The unit is nothing but 6, minus 6. So that is nothing but what? 0, comma minus 6. These are the coordinate points. So I took Z. So one triangle, this is not the only one answer, many answer you can get, different type of answer. Z is nothing but 5 comma minus 6, then I is nothing but 5 comma 0, then N is nothing but 0 comma minus 6. These are the coordinate points of right angle triangle. Okay, now look at here, what is what they are asking, find the length of the three sides. What is the length of IZ? That is this length, IZ length. You know, no, Z is the point which is 5 units, which is 6 units from x-axis. So how many units? 1, 2, 3, 4, 5, 6 units. So this is 6 units. Then Z from y-axis, look at here, Z's abscissa is 5, Z's ordinate is 6. So Z from the x-axis it is 6 units and from the y-axis it is 5 units. So the length of IZ, is nothing but IZ is equal to 6 units. Then the length of NZ is nothing but 5 units. Okay, then what about the length of NI? So there we need to use the Pythagoras, that is I Z squared plus N Z squared, nothing but 6 squared plus 5 squared units. So NI is equal to 36 plus 25. So NI is nothing but how much? Added, we will be getting 61 units. The hypotenuse length is nothing but 61. One side is 6 unit and the another side is 5 unit. Then the hypotenuse is nothing but 61. This is one right angle triangle. Likewise, we can draw mini right angle triangle. But suppose the same, see, roughly I am going to draw. This is my x-axis and this is my y-axis. Suppose I am going to take a point Z. Here using some scales, I am going to take a point 5 comma minus 6. From this I can draw a perpendicular line like this and a line like this. Then I can join this like this. Also I can get one more right angle triangle. Then counting the units, you can find the length of this side and length of this side, and you can find the next side also. Okay. Now look at the fifth question. What would a system of coordinate be like if we did not have negative numbers? Would this system allow us to locate all the points on a 2D plane? See, I took this one as my x-axis. See, x-axis. Then this is y-axis. They both are meeting each other at O. You know, right side of x-axis positive side, above the origin is y's positive side. Okay, so we will be having positive and positive. We are not, that is, they are asking this, only we are having positive side, no negative side. I am not at all extending this left side and I am not at all taking the below the origin side. So no negatives. Then what will happen? We cannot plot any negative points. We cannot plot minus and plus point, or minus and minus point, or plus and minus point. That is not our 2D system, Cartesian system. Okay, thank you. Look at the sixth sum. What is given are the points. What are the points? M of minus 3 minus 4 and A of 0 comma 0, G of 6 comma 8 on the same straight line. So you're going to check these points are in the same straight line. Suggest a method to check this without plotting and joining the point. So you should not plot the point. We should not join the point, but we need to check whether the points are on the same straight line or not. Okay, so look at the straight line. If suppose this is a straight line, 1 minute. Take a straight line and just place the points. Okay, this is one straight line and one more straight line I'm going to do. Because the points may be any order. The order is not mentioned there. So points may be in any order. So what to do? There are three possible orders. So we can check all the three. Look at here. The points, suppose they are the straight, the points are in straight line, means it would have arranged like this: M, A, and G. Or it should be A, G, M. Or it should be G, M, A. So how to check whether the points are on the same straight line? If distance between MA plus AG will give the distance between MG, means the 3 points are in same straight line. In such a way, AG plus GM gives AM, then the points are same straight line, or else GM plus MA will give AG, then the 3 points are same straight line. So what is the condition here? If we are getting MA plus AG is equal to NG, or AG plus GM is equal to AM, or GM plus MA is equal to GA. So in this manner, if you are getting this answer, then we can say all the 3 points are in the same straight line. Otherwise, the points are not in the same straight line. We can conclude that the points are not in the same straight line. Let's check the distance. Okay. So first, find the distance between MA. So M is the point and A is the origin. So you know the formula very well, distance formula. The distance between the point to the origin is nothing but just x squared and y squared. Square and sum it. So minus 3 squared and 4 squared is 9 plus 16, nothing but square root of 25 is 5 units. Okay, clear? Yeah. Now, take the distance between A and G. Again, A is the origin point and G is some point on the plane. So that is also nothing but x squared plus y squared. So 6 squared plus 8 squared is nothing but square root of 36 plus 64 is square root of 100. Okay, square root of 100 you know very well, that is 10 units. Okay, you know the square numbers very well. And look at the total distance, that is mg. Both are different points. So use our distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square under the root. We need to check. So 6 minus into minus will become plus 3 the whole square plus 8 plus 4 the whole squared gives, what is the answer? 6 plus 3, 9 squared, 8 plus 4, 12 squared is equal to 81 plus 144. Which is nothing but add it, we will be getting 225. So you know very well 225 is what? 15 into 15, you will be getting 225. Okay, so 225 square root is nothing but 15. So here we are getting 15 units. 15 units. So what is the conclusion we can get here? MA plus AG. What is the length of MA? 5 units, and AG is nothing but 10 units. If we are adding, we are getting 15 units. That is nothing but our MG. That means, what is that? Sum of MA plus AG gives the total length. So all the 3 points are in the same straight line. Okay, therefore M, A, G on the same straight line. Okay, in other words, we can call these 3 points are the collinear points. Okay, what is the meaning? Collinear points. That 2 or more than 2 points are in the same straight line, the points are called the collinear points. Okay, let's see the next question. Use your method, that is from problem 6. Check the point R, B and C are on the same straight line. Now plot both sets of the points and check your answer. Already I plotted the point. Look at the graph. Already I plotted the point. This saffron color line denotes the sixth question straight line. Okay, the point plotted there A, G, M, and the blue color line shows the seventh question straight line. Okay, the points R, B, and C. You can see that one. Now we can check using the same method which we used in the sixth question. We can use here and check whether the 3 points are in same straight line or not. RB. So what is the distance between R and B? Minus 2 minus into minus plus 5 the whole squared plus minus 5 minus into minus plus 1 the whole squared. So that is equal to 3 squared plus minus 4 squared is nothing but 9 plus 16 is square root of 25. So RB distance is 5 units. Okay. Yeah. The next one, BC. Check the distance between BC. What is BC? 4 minus into minus plus 2 the whole squared minus 12 minus into minus plus the whole square is equal to 6 squared plus minus 7 the whole squared is nothing but 36 plus 49. So length of BC is nothing but, distance between BC is nothing but 85 units. Okay, now find the distance between R and C, RC. So 4 minus of minus plus 5 the whole squared minus 12 minus into minus plus 1 the whole squared is nothing but 9 squared plus minus 11 the whole square. What is the answer here? 9 squared is square root of 81 plus 121 is nothing but 202 units. Okay, now clearly 3 units are here. One is 5 unit, another one is square root of 85, another one is square root of 202. Okay, so we know clearly we can conclude here RB plus BC, that is 5 plus square root of 85 does not equal to 202. That is what? That is not equal to RC. Okay, so we can say the 3 points are not on the same straight line. So we can say the 3 points are the non-collinear points. So what is the conclusion here? R, B, C are non-collinear points. Okay, you can see that in here in the graph. Clear? We can see the next question. Look at that, very easy question. Easily you can get the answer. For this question, only one answer is not there. Many answer you can get. Different type of answer, different type of students can get. Look at the question. What is given there? Using the origin as one vertex, plot the vertices of a right angled isosceles triangle. So you know very well what is isosceles triangle. Isosceles triangle means if two sides are equal and the third side is not equal, then that triangle called as the isosceles triangle. So they are asking the right angle. Right angle means, look at here, and the condition given here, you must take origin as one vertex of the given triangle, one of the vertices. Okay, so O of 0, 0. Then you can draw a right angle isosceles triangle. You know very well x-axis and y-axis intersecting each other at 90 degrees. So here also 90 degree and here also 90 degree, here also 90 degree, here also 90 degree. So anywhere with any unit we can draw the triangle. So different type of triangles we can draw here. Okay, suppose I going to take in x-axis 2 units and the same y-axis also 2 units. This is nothing but 2, 0. This is nothing but 0, 2. So when I am joining this 2, I am getting a triangle, right angled triangle. Okay, same way this side also. Here also many, if I am taking 1 unit or 3 units, anything I can get isosceles triangle, because here also 2 units and here also 2 units. Suppose here I am going to take 1 unit. This is a point and this is a point. If I am joining this, this is also another right angle triangle. Suppose here I am going to take this point. What is the point? Minus 3, 0. And the same way here I can get minus 3, 0, minus 3. When I am joining this two, once again I can get another one triangle. Okay, joining these 2 points, I can get another right angle triangle. Okay, like this many triangle we can get. So name the triangle. For example, A, B, C, D, E, F. Like this, many triangles we can get. That is what triangle AOB. In this angle O is equal to 90 degree. Then and side OA is equal to OB is equal to 2 units. So isosceles right angle triangle. Say triangle COD. COD. In that angle O is equal to 90 degree. What about the side length? And side length OC. Length of OC and length of OD both are what? OC is equal to OD is equal to 1 unit. Okay. Say triangle. What is that? EOF. EOF. In this angle O is equal to 90 degree and OE is equal to OF is equal to 3 units. So many isosceles right angle triangle we can draw like this. Now look at the next question. An isosceles triangle with one vertex is in third quadrant and another in the fourth quadrant. Very particularly, one is in there in the third quadrant, another one is there in the fourth quadrant. Okay. That too isosceles means how to take. Look at here. One condition is given, one point, one vertex is the origin. So take O 0, 0. That is definite. Now, this is your third quadrant. You know very well which is your third quadrant and which is your fourth quadrant. This is your, wait 1 second. Yeah, this is our third quadrant. This is our fourth quadrant. You know very well. So if you are taking the mirror image, suppose say this is 1, here 1 and 2, 3, and here -1, -1, -2, -3. Suppose I'm going to choose a point -1 in the third quadrant, definitely I should choose a point 1 in the fourth quadrant, mirror image. Then only we can get the isosceles right angled triangle here. Okay, so if I'm joining this to this, definitely I will be getting isosceles right angle triangle. And you can choose 2, -2 in the third quadrant, +2 in the fourth quadrant, and joining this 2 you will be getting another right angle isosceles right angle triangle. So joining this point, these 2 points, we will be getting another isosceles like this. You can get many isosceles right angle triangle. The condition for that is nothing but one vertex is in the origin, the other two are, one is there in the third quadrant, another one there is in the fourth quadrant. Like this, you can draw many triangles. Okay. Now look at the 9th question. The following table shows the coordinate points S and T in each case. State whether M is the midpoint of the segment ST. Justify your answer. Okay. They are asking you whether M is the midpoint of ST. So take a line segment. Look at here. So if this is my line segment, say this point is S point and this point is T point. If I am getting M as the midpoint means how my answer should be, that is S M is equal to MT, that is M is dividing both the side in equal ratio, then M is the midpoint, otherwise M is not the midpoint. So you have to check whether SM is equal to MT or not. Then you should check SM plus MT will use ST or not. Then only we can conclude that M is the midpoint of ST, otherwise M is not the midpoint of ST. Okay. So once again we can use what formula? The same distance formula. Okay. So in first case, 4 cases are there. So we will see one by one. So SM is equal to origin point -3 the whole square, 0 is nothing but square root of -3 the whole square is nothing but 3 units. Okay. Then MT is equal to square root of 3 squared plus 0 is equal to square root of 3 squared is nothing but 3 units. Okay. What about ST? ST is equal to square root of 3 minus into minus plus 3 the whole square plus 0 is equal to 6 squared plus 0 is equal to 6 units. Now check the condition. What is the condition I told? Sm is equal to mt. Yeah, we got here Sm is equal to 3 unit and mt is equal to 3 units. So Sm is equal to mt, and when I am adding Sm plus mt, that is 3 plus 3 is equal to 6 unit. That is nothing but Sc. So what can you conclude here? Therefore, M is the what? Midpoint of SC. Okay, no doubt M is the midpoint of SC. Likewise, you need to check for all the remaining cases also. So SM is equal to square root of 3 minus 2 the whole square plus 4 minus 3 the whole square is equal to 1 square plus 1 square is equal to square root of 2 units. Then MT is equal to square root of 4 minus 3 the whole square plus 5 minus 4 the whole square. Once again, you will be getting 1 square plus 1 square is equal to square root of 2 units. Okay. Then next, SE is equal to square root of, what is that? 4 minus 2 the whole square plus 5 minus 3 the whole square is equal to 2 square plus 2 square is equal to, what is that? 4 plus 4, 8. Square root of 8 is nothing but 2 root 2 units. Okay. Now we got Sm is equal to Mt is equal to root 2. Okay. And Sm plus Mt is equal to root 2 plus root 2. You know very well, both are like irrational. So we can add 2 root 2, which is nothing but St. So what is our conclusion? Here also M is the midpoint. So it implies M is the midpoint of SC. Okay. Now look at the next case. SM. S is the origin. So 0 plus 5 squared is equal to 5 units. Then MT is equal to 0 plus minus 10 minus 5 the whole square is equal to square root of 15 squared is equal to 15 units. Okay. Then ST. You know very well, square and square root get cancelled. Otherwise, 15 squared is nothing but 225. Square root of 225 is nothing but 15 units. Okay. Now, next one is the origin. S is the origin. So, 0 plus minus 10 the whole square is equal to 10 square is equal to 10 units. So, what happened here? In first case itself, you can conclude Sm is not equal to Mt, because Sm is 5 unit, Mt is 15 unit. So, Sm is not equal to Mt. But Sm plus Mt is equal to 5 plus 15 is equal to, sorry, not 5 plus 15, Sm plus St. Sm plus St is equal to 5 plus 10 is equal to 15 units. That is nothing but our Mt. So these 3 points are on the same straight line, but M is not the midpoint of St. Okay. So what is the conclusion? Yes, Mt are on the same straight line, but what Sm is not equal to Mt, therefore M is not the midpoint of St. Okay, in third case, M is not the midpoint of St. What about the fourth case? Let's check. Check the fourth case. Sm is equal to 0 plus 8 the whole square plus minus 2 minus 7 the whole square is equal to 8 squared plus minus 9 squared is equal to 64 plus 81 is nothing but 145. Okay. What about MT? MT is equal to 6 minus into minus plus 8 squared plus minus 3. Sorry, I wrote wrongly. 1 minute. MT. So like this, you may do any mistake. So be careful while writing the distance. See the coordinate points correctly, then write 6 minus 0 the whole squared plus minus 3 plus 2 the whole squared. That is equal to 6 squared minus 1 squared is equal to 36 plus 1 is equal to square root of 37. Next, SG is equal to 6 minus into minus plus 8 squared plus minus 3 minus 7 squared is equal to 14 squared plus minus 10 squared is equal to 196. 14 squared is equal to 196. So we are getting 296. Okay. So one length is 145 units. Another is 37 units. Another one is 296 units. So definitely, so what is the condition here? ST is not SM is not equal to MT. That implies M is not the midpoint of it. That's all. Okay, clear? Now look at the next question. 10th question. Use the connection you found to find the coordinate of B given that M of minus 7 comma 1 is the midpoint of A of 3 comma minus 4 and B of x comma y. So you need to find what is the coordinate point of B. Okay. So what is the conclusion we can get from the previous sum? Look at it. See here, when the midpoint is given in the midpoint, look at here, M is the midpoint means the S abscissa plus T abscissa, sum of these two abscissa divided by 2, that is average of that two, nothing but M's abscissa. Okay, and look at here, in first case, what we got, case 1, once again we will see the case 1 result, minus 3 comma 0, 0 comma 0, 3 comma 0. That is S is minus 3 comma 0 and T is 0 comma 0, M is 0 comma 0. S is minus 3 comma 0, minus 3 comma 0 and M is 0 comma 0, T is 3 comma 0. Okay. So if M is the midpoint, how it will be? Add the abscissas of S and T. Minus 3 and plus 3 divided by 2. Average of the abscissa 0 by 2 is equal to 0. That is the abscissa of the midpoint. Then next is y ordinate of S and ordinate of T. Sum of these two ordinate divided by 2 is equal to 0. So midpoint coordinate point is 0 comma 0. That is average of abscissa and average of ordinate will give the midpoint coordinate point. Okay, look at the second case. What is this? 2 comma 3, 3 comma 4, 4 comma 5. 2 comma 3, 2 comma 3, 3 comma 4 and 4 comma 5. Okay, now average of the abscissa, that is 2 plus 4 by 2 is equal to 6 by 2 is equal to 3 unit. Okay, that 3 unit nothing but abscissa of the midpoint. Same way, ordinate, average of the ordinate of the extreme point. 3 plus 5 by 2 is equal to 8 by 2 is equal to 4. Okay, now midpoint M's abscissa is 3, ordinate is 5. So we can conclude here that is midpoint formula is nothing but x1 plus x2 by 2, comma, y1 plus y2 by 2. That is, if you are taking a point A of x1, midpoint of AB, okay? For suppose here, A's coordinate point x1, comma, y1 and B's coordinate point x2, comma, y2 means midpoint is nothing but average of the abscissa, comma, average of the ordinate. This is the conclusion we got in question number 9. Okay, with that conclusion, we can solve the 10th sum. So what is given? A is a point c, comma, minus 4 and B is a point x, comma, y. Then midpoint of AB is nothing but m of minus 7, comma, 1. Now use that formula. Midpoint of AB is nothing but m of abscissa 3 plus x by 2, sum of the two abscissas, and sum of two ordinate 4, comma, y by 2 is nothing but m of minus 7, comma, 1. Okay, sum of these two by 2, then sum of these two by 2. Okay, now compare both the side m point we wrote. Now compare the abscissa to abscissa and ordinate to ordinate. So what you will be getting? 3 plus x by 2 is equal to minus 7. Solve it. 3 plus x, transpose it. 2 will be transposed to next side. So 2 into minus 7 gives minus 14. Okay, then our x is nothing but x is equal to minus 14 minus 3, x is equal to minus 17. What about the next one? Now compare the ordinates. Minus 4 plus y by 2 is equal to 1. Transpose 2. So minus 4 plus y is equal to 2. Y is equal to 2 plus 4. Y is equal to 6. Okay. So these are the coordinate points for which one? Point B. So point B nothing but minus 17, comma, 6. Okay. Thank you. Read the 11th sum. Let P and Q be the point of trisection of AB with P closer to A, P closer to A and Q closer to B. Using your knowledge of how to find the coordinates of the midpoint of line of a segment, how would you find the coordinate of P and Q? Do this for the case when the points A 4, 7 and B 16, minus 2. Okay, so we will take a line segment. This is the line segment. Okay, what's our line segment? That is A and B, AB. AB is our line segment. So A. The coordinate of A is given 4, 7 and this is B. Coordinate of B is given as 16, minus 2. Okay, and what is given? 2 points P and Q trisected this line segment. P is one point closer to A and Q is another point closer to B. We don't know the coordinates of P and Q. So let's take the coordinates P of x1, y1 and Q of x2 and y2. So we're going to find this using our midpoint because P and Q dividing A, B into 3 equal parts. This is first part, second part, third part, 3 equal parts. In this, the meaning of this is nothing but P of x1, y1 is the midpoint of which one? A of 4, 7 and Q of x2, y2. As well, Q of x2, y2 is the midpoint of P of x1, y1 and B of 16, minus 2. Okay, you know the midpoint formula. So P of x1, y1 is equal to P of average of abscissas of A and Q, nothing but 4 plus x2 by 2. Then average of ordinates of A and Q, that is nothing but 7 plus y2 by 2. Okay, so now compare the abscissa to abscissa and ordinate to ordinate. Abscissa to abscissa, what you will get? X1 is equal to 4 plus x2 by 2. Okay, now solve it. You will be getting an equation. 2 is there in the division. While we are transposing this to this side, it will become multiplication. So 2x1 is equal to 4 plus x2. Once again transposing x2 to the left hand side, you will be getting 2x1 minus x2 is equal to 4. We can take it as first equation. This is our first equation. Now comparing the ordinate, that is y coordinates, y1 is equal to 7 plus y2 by 2. Okay, now the division will be transposed to the left hand side, 2y1, 7 plus y2, and y2 transposed to the next side, y1 minus y2 is equal to 7. This is your second equation. Okay, so we got two equations. We need to solve this. This is our first equation. That is our second equation. Now, one more point we are having. What is that? Q of x2, y2 is the midpoint of which one? P of x1, y1. Q is the midpoint of P and B. B of 16, minus 2. Okay. Once again, use the midpoint formula. What is our midpoint formula now? Q of x2, y2 is equal to Q of average of the x coordinates of P and B. That is nothing but x1 plus 16 by 2. Average of y coordinates of P and B. That is nothing but y1 minus 2 by 2. Okay. Now compare abscissor to abscissor. x2 is equal to x1 plus 16 by 2. No need to make it as further simplification. Keep as it is. We will substitute this and get the answer. Now compare the ordinate. What you will be getting? y2 is equal to y1 minus 2 by 2. So this is our y2. Okay. We got now x2 and y2. Now I am going to substitute my x2 in first equation and I am going to substitute y2 in the second equation. Okay. So what's my first equation? 2x1 minus x2 is equal to 4. So 2x1 minus x2 is nothing but x1 plus 16 by 2 is equal to 4. So take LCM. 4x1, removing the bracket, we need to multiply minus to the two terms inside the bracket. So minus x1 minus 16 by 2 is equal to 4. Transposing 2 to next side, at the same time add this to 4x1 minus x1 will become 3x1 minus 16 and 4 2s are 8. 3x1 is equal to 8 plus 16. 3x1 is equal to 24. So our x1 is nothing but 24 by 3, 8. Our x1 is 8. Now what about our x2? We are having x2, nothing but what is that? x1 plus 16. So x2 is equal to x1 plus 16 by 2 is equal to 24 by 2 is equal to 12. So our x1 is 8. So what we got here? x1 is equal to 8 is one answer. And x2 is equal to 12 is the another answer. Same way we will find y2. What's our y2? y2 is equal to y1 minus 2 by 2. Now substitute y2 in second equation. What's the second equation? 2y1 minus y2 is equal to 7. So while we are substituting 2y1 minus of y1 minus 2 by 2 is equal to 7. So take LCM. As well as remove the bracket. Minus y1 minus into minus becomes plus 2. Okay, in this place you need to be very particular. Multiply minus and minus. Okay, take it as plus. Now 4y1 minus y1 is nothing but 3y1 plus 2. Transpose 2 to next side, then 7 will become 14. So 3y1 is equal to 14 minus 2. So 3y1 is equal to 12. So y1 is equal to 4. So y1 is 4. Then what about our y2? Replace it. Our y2 is nothing but y1 minus 2 by 2. Okay. So that is y2 is equal to 2 by 2. 2 by 2. y2 is 1. So we got x1, x2, y1, y2. What about our coordinate points? P's coordinate point x1, y1, which is nothing but P of 8, y1 is 4. Okay, then Q's coordinate points x2, y2, nothing but Q of x2 12, y2 1. So these are the coordinate points dividing our segment AB into 3 equal parts. Clear? Let's see the next sum. Look at the 12th question. Given A 1, minus 8, B minus 4, 7 and C minus 7, minus 4. These are the 3 points. So that they lie on a circle K. Now our circle, look at the circle. Adjacent side we are having a circle. No, this circle is nothing but K. Okay, it is given K is a circle whose center O of 0, 0. So our center is O of 0, 0. So we need to show this A, B, C are on the circle. So let's take this point A. Then let's take this point B. That is, the point is 1, minus 8. The point is minus 4, 7. And let's take the point C, minus 7, minus 4. How to show this? We can use the distance formula to show this. What is our distance formula? Distance between O to A, that is the origin to any point. Origin to any point is nothing but that coordinate point square. Square root of x1 square plus y1 square is the formula. If you are getting the distance OA and OB and OC, if you are getting all the 3 distances are same, then the points are on the circle. If they are not equal, then they are not on the circle. Let's check that. Find OA. Using the distance formula, find OA. OA is equal to square root of 1 squared plus minus 8 squared is nothing but square root of 1 plus 64 is nothing but 65 units. Let's see OB. That is square root of minus 4 squared plus 7 squared is equal to minus 4. Minus into minus 4 plus 16. Then 49. Summing up this two, once again we are getting 65 units. OC. What about OC? X coordinate minus 7 the whole square, y coordinate minus 4 the whole square, minus into minus plus, 7 7s are 49 and 16. Once again this is nothing but 65 units. It means what we got? OA is equal to OB is equal to OC. That is equal to square root of 65 units. All the 3 distances are same. That's why what is the conclusion can given here? A, B, C are on the circle K. The 3 points are on the circle K. What is it? What is the radius of the circle K? Radius of circle K nothing but square root of 65 units. You know the definition of circle, no? Circle is a collection of point which is equidistant from the center. So A, B, C are equidistant from the center. So they are lie on the circle. So that the radius is nothing but that distance. Okay. Look at the next subdivision. Here it is given D minus 5, 6 and E 0, 9 are 2 points. We need to check whether DE lie within the circle. So this is very important point. See, within the circle, on the circle, outside the circle. You have to check these 3 points within the circle or on or outside. How to check? For example, I am going to take a point now. This is the same circle K with center 0, 0. For example, I am going to take a point P, which is inside the circle. And I am going to take a point Q, which is on the circle. I am going to take a point R, which is outside the circle. Okay, the circle having 3 parts. Circle having 3 parts. What are the 3 parts? Inside, on the circle, outside the circle. These are the 3 parts of the circle. The points divided in a plane. The points divided into 3 parts using a circle. First part inside the circle. Second on the circle. Next outside the circle. So infinitely many points are there. How to check? Now look at here PQ. What about the distance PQ? What about the distance? What about the distance O? OQ and OR. How it should be? Definitely OQ. Okay, Q is on the circle, so this is nothing but the radius. Okay, how about OP? OP is definitely less than the radius. OQ is equal to the radius. And what about OR? OR is greater than the radius. Okay, when the distance is less than the radius, the point lie inside the circle. It is equal to the radius, the point lie on the circle. It is greater than the radius, it is outside the circle. Using this concept only, we are going to check. Now check the distance OD. OD is equal to minus 5 the whole square plus 6 the whole square is equal to 25 plus 36. How much? While we are adding, you will be getting 61 units. Okay, compare the 61 units because we are having the same circle K. No, what is the radius of the K? Radius of K is square root of 65 units. Now compare this to square root of 61 is less than square root of 65. That implies D is inside. D lie. Okay, D is inside the circle. Okay, lie within the circle. D lie within the circle. Now check OE. OE is equal to square root of 0 squared. OE, 1 minute. Yeah, we will continue. See, OE is equal to square root of, coordinate points are 0 and 9. So 0 square, 9 square is nothing but square root of 81. 0 plus 81. So 81 units. So length of OE, otherwise distance between E and O is nothing but 81 units. It's very, very clear. 81 is greater than square root of 65. That is greater than the radius. Okay. Here 61 is less than the radius. So that D lie within the circle, inside the circle. Now 81 is greater than the radius. Therefore, E lie outside the circle. Okay, maybe D may be somewhere here, E may be somewhere here. One of the outside point E and one of the inside point D. Okay? We will do the next sum. See the solution of the next sum. 13th sum. The midpoint of the sides of a triangle ABC. Okay, look at the triangle ABC. Sides of the triangle given as ABC. Take this as side A. This is side B. AB. The vertex A vertex, B vertex and C vertex. Okay, A, B, C. And D, E, F are the midpoint of sides ABC. So take D is the midpoint of BC and E is a midpoint of AC and F is a midpoint of AB. And what is given? The coordinates of D, E, F given as E is nothing but 5, 1 and D is given as 5, 1, E 6, 5 and 0, 3 is nothing but our F. Okay. So find the coordinates of ABC. So ABC we don't know. We will take it as x1, y1 and x2, y2 and x3, y3. These are the coordinate points. Okay. How to find this? Now, once again we will use the midpoint formula. What is the midpoint here? D. D of 5, 1 is the midpoint of which one? B of x2, y2 and C of x3, y3. So what's our midpoint formula? D of x2, x3 by 2, y2 plus y3 by 2 is equal to D of 5, 1. So compare the ordinate abscissa. X2 plus x3 by 2 is equal to 5 and ordinates y2 plus y3 by 2 is equal to 1. Come on. make it as a equation x2 plus x3 is equal to, multiply this, we will be getting 10. So x2 plus x3 is equal to 10. Here y2 plus y3 is equal to 2. So consider these two equations. Okay, we got two equations. Say this is the first equation, this is the second equation. Now E of 6, 5 is the midpoint of which two? A of x1, y1 and C of x3, y3. Now use our formula. E of x1 plus x3 by 2, y1 plus y3 by 2 is equal to E of 6, 5. So compare x1 plus x3 by 2 is equal to 6 and y1 plus y3 by 2 is equal to 5. Okay, now we got a equation x1, x3 is equal to 12. This is one more equation, name it as the third equation. Then transpose 2 to next side, you will be getting y1 plus y3 is equal to 10. Name it as the fourth equation. We are having 6 unknowns. What are the unknowns? x1, x2, x3, y1, y2, y3. All the 6 unknowns. No, we need 6 equations and we need to solve the, then only we can find the answer. Now one more f. Okay, one midpoint. F is the midpoint of A and B. So f of 0, 3 is the midpoint of A of x, 1 and B of x2, y2. Okay, A and B. F is the midpoint of A and B. Now f of x1 plus x2 by 2, y1 plus y2 by 2 is equal to f of 0, 3. Comparing the x coordinates, x1 plus x2 by 2 is equal to 0, y coordinates, y1 plus y2 by 2 is equal to 3. Transpose it, x1 plus x2 is equal to 0, 2 into 0 is 0. So this is our fifth equation. Okay, here y1 plus y2 is equal to, multiply this 6. This is our sixth equation. The sixth equation. Now 1, 3, 5 we are having the variables. First equation x2, x3. That is x2 plus x3 is equal to 10 is our first equation. Then x1 plus x3. x1 plus x3 is equal to 12 is our third equation. x1 plus x3 is our third equation and x1 plus x2 is equal to 0 is our fifth equation. So on solving this, we will be getting x1, x2, x3. Okay. So from the fifth equation, get it, x1 is equal to minus x2. Okay. Now substitute this. Substitute x1 in the previous one, that is third equation. What is your third equation? x1 plus x3 is equal to 12. So instead of x1, replace minus x2 plus x3 is equal to 12. This is our new equation. Say this is seventh equation. Okay. Now what is our first equation? Write as it is. Second, x2 plus x3 is equal to 10. This is our first equation. Already we have. What we are going to do? We are going to add our seventh equation and first equation. So 7 plus 1. 7 plus 1, when we are adding minus x2 plus x2 cancelled, eliminated. x3, x3, 2x3, x3 plus x3 will become 2x3, then 22. So x3 is nothing but 11. 2x3 is given as 22. So x3 is, we got x3 11. Then now x3 is 11. What to do? Look at equation 1. Replace x3 in the first equation. Take the first equation. Replace it. x2 plus 11 is equal to 10. So what about your x2? x2 is equal to 10 minus 11. x2 is equal to minus 1. So we got x2. Okay, what is the relation between x2 and x1? See, here we got x1 is equal to minus x2. Okay, so What's your x1? x1 is equal to minus of minus 1. So x1 is nothing but, what is your x1? x1 is nothing but minus into minus plus 1. Like this only you need to solve the equations. When 6 unknowns are there, we can use the substitution method or elimination method to find this. So we got x1 is plus 1, x2 is minus 1, x3 is 11. Same way we can solve the next 3 variables. What are they? y1, y2, y3. Write all the equations. Second equation, y2 plus y3 is equal to 2. y2 plus y3 is equal to 2. Then y1 plus 4, this is our second equation. Then fourth equation is nothing but y1 plus y3. Fourth equation, y1 plus y3 is equal to 10 is our fourth equation. Then sixth equation, y1 plus y2 is equal to 6. That is our sixth equation. Now solve this. How to solve? Once again, from the sixth equation, take y1. So y1 is nothing but 6 minus y2. Now substitute this y1, in the fourth equation. So fourth equation becomes y1 is nothing but 6 minus y2. Okay, instead of y1, we will write 6 minus y2. Fourth equation, y1 minus y3. 6 minus y2 plus y3 is equal to 10. Now, transpose this plus 6 to that side as minus 6. Minus y2 plus y3 is equal to 10 minus 6. Minus y2 plus y3 is equal to 4. Take it as 8th equation, new equation. Now, look at your second equation. What's your second equation? y2 plus y3 is equal to 2 is your second equation. Now, what we're going to do? We're going to add 8th equation and the second equation so that we can eliminate y2, minus y2 and plus y2. We can add y3 plus y3 as 2y3. 4 plus 2 is nothing but 6. So, what's your y3? 3. 6 by 2, 3. So, we got y3. Now, substitute y3 in some other equation. Which one we can substitute? Once again, fourth equation. Take fourth equation. Fourth equation involved y1 and y3. y1 plus 3 is equal to 10. So, what's your y3 here? y1 here. y1 is equal to 10 minus 3. y1 is equal to 7. So, we got y1. What about y2? Which equation we can replace? y2. Take the sixth equation. y1 plus y2 is equal to 6. So, sixth equation. y1 plus y2 is equal to 6. So, y2 is equal to 6 minus 7. y2 is equal to minus 1. So, this is our y2. Okay. So, now we got all the variables x1, x2, y1, y2, everything. Now, find the coordinate points. What are the coordinate points of A? A is nothing but x1, y1. Okay. Now, x1 is equal to 1, x2 is equal to minus 1, x3 is equal to 11. Then y1 is equal to 7, y2 is equal to minus 1, y3 is equal to plus 3. Therefore, the coordinate points A of x1, y1 is equal to A of 1, 7. Then B of x2, y2 is equal to B of minus 1, minus 1. C of 11, x3, y3. C's coordinate points, we took it as x3, y3. C of x3, y3 is equal to C of 11, 3. So, these are the coordinate points of the triangle A 1, 7, B minus 1, 1, C 11, 3. Thank you. Students, today we are going to see the solution for 14, 15, 16 questions in this video. Look at the 14th question. A city has two main roads which cross each other at the center of the city. These two roads are along the north-south direction. It is denoted as NS, and east-west direction denoted as EW. You can see here, look at the picture. Look at the diagram. So this is north-south direction. This is east-west. All the vertical lines are north-south, or the horizontal lines are east-west. Okay. All the other streets of the city run parallel to each other. You can see all the lines here. 1, 2, 3, 4, 5, like that. All the cities parallel to each other. Here also 1, 2, 3, like the cities parallel to each other. Okay, what is the scale they took? 1 centimeter is equal to 200 meter. Okay, this 1 centimeter, this is nothing but 200 meter. Here also 1 centimeter, nothing but 200 meter. Likewise, everywhere the same scale. With that, you need to draw the diagram in your graph sheet. So how to draw the diagram? For example, I'll show to you. Look at here, take out your graph sheet. In that, fix your x and y axis. You know that the horizontal line is your x-axis. So draw the x-axis. Use your scale and pencil and draw the x-axis. I'll try to draw it. Using your scale pencil, exactly you can draw, but I'll try. Okay. Somehow my x-axis fixed here. Okay. Then y-axis vertically. Fix your y-axis vertically. So this is my y-axis. It's clear. Okay. X-axis, y-axis, name it as x, x dash, y, y dash, enter 0, 0. Now, north vertical lines shows the north-south direction streets. Okay, so this is north-south direction street. Say, draw a line like this and name it as street 1. Next, street 2. Street 2. Street vertically. Street 3. Okay, likewise this side also. Any diagram, first I shown one diagram, no, that or this, anything you can draw, both are right. This is the next street, then this is the, say, like this. This is one more street. Like that you can draw north south street and east and west horizontal streets. So this is one street. Likewise horizontal streets. Okay, here also you can draw. Totally 10 streets are there. You can draw here. So like this also you can draw your diagram. Okay, this is your first subdivision. You have to draw 10 horizontal line and 10 vertical lines. Okay, this is one example and you can draw like this also. Now look at the question. What is given? There are street intersection in the model. So which is street intersection? Look at here. First street. This is first north south and this is first east west. Both are intersecting here. Okay, 1, 1. That means what? First north south street and east west street, both are intersecting here. For example, I am going to take this. This is 7th north south and east west. say sixth, fifth, these twos are intersecting in this point, that is 7, 5. Okay, like that the streets are intersecting each other. Okay, if the second street running north to south direction and fifth street running east west direction, second street north to south and fifth street east west means this is point of intersection, street of intersection 2, 5. Okay, using this, what to do here? First, A subdivision is how many street intersection can be referred as 4, 3. That means what? Fourth street north south direction and third street east west direction. So look at here, fourth street and third street. So how many intersection can be done here? Only one intersection, 4, 3. In this, only one intersection we can see. Okay, how many street intersection can be referred? 3, 4. What about 3, 4? Third street is here, third street and fourth street, third of north south and fourth of east west. So this is the point of intersection. Again we can see only one, that is nothing but 4, 3. Okay, only one street intersection we can see in 4, 1 and 3, 4. Only one intersection. The next question. A computer graphic program displays image on a rectangular screen. Okay, look at the rectangular screen, and alongside I have given the rectangular screen whose coordinate system has the origin at the bottom left corner. Okay, where is the origin? Bottom left corner. Bottom left corner is this one. Bottom left corner we are having the origin. The screen 800 pixels wide. So width of the screen is 800 pixel and 600 pixel high. So height of the screen is 600 pixel. So this is the entire screen. Here I have shown the entire screen. Okay, 800 pixel wide and 600 pixel height. Entire screen is this one. Okay. A circular icon of radius 80 pixel. Now 80 pixel is drawn with the center at a point A 100, 150. So look at here 100. From the 100 draw the point to the y-axis 150. Here 100, 200, in between the middle point is nothing but 150. So this is 100, 150. So the radius of this pixel is nothing but, this circle is nothing but 80. The another circle drawn here with the center 250 and 230. So 250. This is 200 and 300. In between we are having 250. From this we need to locate 230. Okay, so this is 250. So here we can take it as 230. Nearer to 250, we can take it 230. Okay, the radius of this is nothing but, how much is given? 100 pixel. 100 pixel. Okay, here 80 and here 100. These are the two circles given. Determine whether any part of either circle lie outside the screen. We can see both the circles are inside the screen. Okay, this is the entire screen. So both the circles are inside the screen. So answer for the first question, no. No part of circle lies outside the circle. Second question, whether the two circles intersect each other. Yes, the two circles are intersecting each other. You can see this is the intersection part. So both the circles are intersecting each other. Now see the next question. So what is given? Plot the point A of 2, 1, B -1, 2, C of -2, -1, D of 1, -2 in the coordinate plane. So take a graph sheet as well using 1 centimeter scale. Look at here. 1, 2, 3, 4 positive sides, negative sides, and everything draw and plot the point. Look at the A point, B point, C point, D point. In order, you need to plot the points and join the point and show like this. You can see all the sides are, when we are seeing the sides are equal. So we can conclude it is a square, and what they are asking is ABCD is a square. Can you explain why? What is the area of this square? If suppose it is square, then what is the area of the square? What is the condition for square? Okay, in 8th standard itself you have studied quadrilaterals. In quadrilaterals, the side, how the sides are for the quadrilaterals, according to their sides and diagonals, special names given for the quadrilaterals. When all the sides are equal, all the sides are equal and both the diagonals are equal, then we can call the quadrilateral as square. Then if the two condition accepted, then the quadrilateral is nothing but square. Otherwise, suppose four sides are equal, diagonals are not equal, it is a rhombus. Okay, so now you need to check using our distance formula. If you have to get the condition AB is equal to BC is equal to CD is equal to DA, you need to check this condition, and diagonals AC is equal to BD. If both the conditions are satisfied, then we can say ABCD is a square. Otherwise, we cannot say it is a square. Then we need to find area of the square. The area of the square is nothing but side squared. What is the length of this side? Side square units. This is the area of the square. Now find the distance between AB or length of AB. So AB, B point minus 1 minus 2 the whole square plus 2 minus 1 the whole squared is equal to minus 3 squared is 9 plus 1 is equal to square root of 10 units. Side AB length is 10 unit. Now find BC. What about BC? Minus 2 plus 1 the whole square plus minus 1 minus 2 the whole square is equal to minus 1 the whole square is 1 and minus 3 the whole square is 9, again 10 units. Okay, then next side CD. 1 minute. Now find out CD. What about CD? 1 minus into minus plus and minus 2 minus into minus plus 1 the whole square, again 3 squared 9 plus minus 1 squared 1, 10 units. Okay, what about DA? DA square root of D, 1 minus 2 the whole square plus minus 2 minus 1 the whole square. Yeah, very good. Minus 1 squared is plus 1, minus 3 is 9. So square root of 10 units. Yeah, it is clear that AB is equal to BC is equal to CD is equal to DA is equal to square root of 10 units. So all the sides are equal. All the sides are equal. Okay, but we cannot conclude with this because all the sides are equal, maybe a rhombus or a square. So we need to find whether it is a rhombus or a square using the diagonal length. We need to confirm it whether it is a square or the rhombus. So AC, distance between AC minus 2 the whole squared plus minus 1 the whole squared. AC, A point is 2 1 and B C is minus 2 minus 1. So minus 2 the whole square and minus 1 the whole square is nothing but minus 4 the whole square is 16 and minus 2 the whole square 4 is nothing but 20, square root of 20 units. Okay, then BD, you need to find the distance BD. BD, So what are the coordinate points of B? B -1 the whole squared, -1 the whole squared plus -2 the whole squared.